Good morning, everyone. My name is Uchechukwu Ohajiudu, and I'm a PhD student at the University of Southern Mississippi, and my topic today is on sexual size dimorphism in southern flounder. Southern flounders are commonly found in the South Atlantic region and in the Gulf of, you all can be my guest and fill the blanket to that, but not present at the southern tip of Florida. They belong to the family Paralichthys and are commonly sought for commercial and recreational purposes, with an estimate of about 2,000 tons between the years 2015 and 2019. Recent NOAA and state stock assessment show sign of decline, and there has also been an increase in demand for this species. In order to fill this demand gap, aquaculture is needed for this species. Southern flounders have a very fast growth rate and eerie hairline. That is, they can be cultured in both low and high salinity. And this is important for the Central Gulf because of the low salinity, meaning that in inland recirculatory system and pond aquaculture system, we can eliminate the use of sand, which can drastically bring down the cost of the use of salt, which would bring down the cost of production. They have good flesh quality. And in order to move the culture of this commercial species that isn't viable yet, the use of the understanding of some biological traits, such as sexual size dimorphism, is needed to be very much understood. So sexual size dimorphism are phenotypic characteristics that distinguishes males and females on the basis of color, shape, or size. Size sexual dimorphism favors either males, as in Atlantic salmon, or females, as in flatfish, such as southern flounder. Species show sexual size dimorphism at different stages of development. In the European sea bass, we have an early sexual dimorphism at the post-larval stage, where the females tend to have a faster and higher growth rate compared to the males, and after that period, then the males and the females grow at an equal rate. And in the Atlantic salmon, at the initial stage, there is an equal growth rate with the males and females, and at the onset of maturity, we see a higher and faster growth rate in the males compared to the females. Southern flounder females can be 2 to 3 times bigger than males in size, and although sexual size dimorphism in southern flounder have been reported in previous publication, most data were obtained from the wild, and we do not have that specific point or stage at which sexual size dimorphism can be observed in southern flounder. The management implication in aquaculture is it's important, especially in the separation of sizes. Knowing the right time can maximize your growth production. The monosex of this culture is important, although that is still difficult at the moment because of the complexity in sexual determination. So the objective of my research is to first determine the timing of the onset of the dimorphism, document growth trajectories of males and females to market size. The flowchart above is my experimental design. So 2 males and 2 females were spawned, and from this spawn, we selected juveniles. Juveniles were pit tagged and measured. The image by your right is color-coded. The red represents the females, the gray undifferentiated fish, and the blue the males. So we hypothesized that at the start of the experiment, we did have a lot of undifferentiated fish, and this might have impacted growth, but subsequently, there was complete differentiation, and then we had sex-specific growth as we kept on with the experiment. At the end of the experiment, measurements would be done, the sex would be ID'd, we would look at the weight, length, and carcass. Individual and sex-specific growth parameters will be analyzed. So wild-caught lab maintained broodstock was hormonally induced to spawn, and 120 to 200-day post-hatch juvenile southern flounders were pit tagged with an initial weight ranging between 5 to 69 grams and a mean of 25 grams. And the length range between, initial length range between 7 and 17 centimeters with a mean length of 12 centimeters. Two recirculated aquaculture system was used with 3 replicate tanks per system, and stocking density was at 20 fish per tank. We did have 2 temperature treatments, and in the first treatment tank, we had a constant optimum of 26 degrees Celsius, and in the second, we started with a 26 degrees Celsius. Then at 298 days post-hatch, this temperature was gradually dropped to 18 degrees Celsius. And so the reason we did this is to induce maturation, which in some publication has been shown to influence sexual size dimorphism. Water quality parameters were maintained, and sampling and biometry were done every 6 weeks for weight, length, and the span length. I would like to state that the experiment is still ongoing and that data presented in this result are still at the preliminary stage, and sex hasn't been individually identified for the southern flounders. Well, so the graph above is growth between systems, and on our x-axis we have our sampling date, on the y-axis we have our weight in grams. There are 2 different color codes. The blue represents system 1, where temperatures were dropped to 18 degrees Celsius, while the orange represents system 2, where temperatures were maintained at an optimum of 26 degrees Celsius. There's a shaded gray area. This represents the period where we had system 1 at 18 degrees Celsius for 60 days. So at the start of the experiment, we didn't see any difference in weight until we got to the last 2 sampling points. Yes, we did observe significant system effect, but we did observe significant system effect in the weight, but this weight, the difference in the weight was minor compared to the huge difference in temperatures of 8 degrees, which signified that even at 8 degrees and 26 degrees Celsius, that southern flounders grew at the same rate, which in aquaculture is very, very important. There was also a significant tank effect on weight, and this was observed in a particular tank, and despite the fact at the initial start of the experiment, selection was done randomly, we hypothesized that there was this particular tank that had more females, and this is the reason for the growth difference. So here is a plot. On our x-axis, we have our sampling date, and on our y-axis, we have our weight in grams. And this plot is an increase in weight of the southern flounder, and this represents each individual sampling point at every sampling date. The idea was to see if we are going to see a distinct difference in groups, as seen in publications from different sexual size dimorphism papers, but there is no clear indication. There is no clear indication in difference in group differentiation here. This plot shows the weight-specific growth rate of southern flounders. On our x-axis, we have our sampling date. On our y, we have our specific growth rate as a percentage gram per day. And sexual specific growth rate is supposed to be independent of size and should assume an exponential growth rate, but we don't see that because at each sampling point we see reduction, we see a decline in specific growth rate. This is common in aquaculture, but then we did see a parallel growth rate, and we see SGRs compact at our last sampling point. So this observation made us to look at distribution at an individual specific growth rate, at an individual sampling point. My bad. So this is the weight. On our x-axis, we have the weight. On our y-axis, we have our specific growth rate. And this was done in the first sampling point. And so we did observe that linear, that decline, the linear decline in weight, and as we can see, the highest weight had low SGR as compared to the low weight. The same observation was made from the second sampling date, but then on the third sampling date, we see a sort of plateau in our linear, in our negative linear in SGR. But then on the last sampling date, we no longer see that decline in linear progression in SGR. And so for this, we hypothesized that the females started growing bigger and started growing faster and have a higher growth rate as compared to the males. As we can see within this area, we see an anomaly where we have a high weight with a very high SGR as compared to areas around here where we see a low weight with a low SGR. So we hypothesize that females start showing sexual size dimorphism, but again, we haven't sexually ID'd the fish, and so we don't know at the moment. In conclusion, larger fish showed a higher SGR in the last sampling interval, which may indicate the onset of dimorphism, and this was probably before 366 days post-hatch, with a length of 26.6 centimeter and a weight of 269 grams. The next step of this experiment would be to monitor growth until market size of 12 inches, which is commonly used in Mississippi State, identify the sex of individual fish. We're going to look at sex-specific growth by observing the GSI, carcass, fillet, and then develop growth model. Future research would include the effect of environmental factors on maturation, on sexual size dimorphism, look at genetic variations on sexual size dimorphism, and sex determination and sex control. My dissertation is focused on sex determination and sex control, where I'll be looking at the influence of temperature and salinity and different genetic factors and how they influences sex in southern flounder. I would like to acknowledge the University of Mississippi, the staff at the TAG Cochran Marine Aquaculture Center, my fellow colleagues at Dr. Eric Seland's lab, Brooke, Tammy, Chelsea, and Laura, and the staff of Mississippi State, the staff of Mississippi Department of Marine Resources. Thank you.
Regarding your future experiments, about environmental factors that influence that, about regarding light, what do you think about that?
Sorry?
What do you think? What do you want to try regarding environmental factor as light?
Okay, so so we're looking at temperature and salinity, and we want to see how that would influences the sex determination in southern flounders, because they have an environmental sex determination system. And so we want to design a protocol that hopefully we can achieve of 50% female, because the males are already fixed, and so we can only go as high as 50% females in terms of population.
Thank you. Question?
I'm not sure if you mentioned this or not, but are these fish individually tagged so that we can actually watch the growth and adjust which one's male and female, just to make sure that it's the same as
Yes, we individually tag them.
Can you repeat it, please?
Sorry?
Can you repeat this question so we
Oh, okay. So he asked if each individual fish were pit tagged at the start of the experiment, and yes, each individual fish were pit tagged at the start of the experiment.
How do you sex the flounder?
So at the end of the experiment, we would sex them by visual observation of gonads. We'll have to look at the gonads, and if there is need, we would do a histological study at the end of the experiment.
Also, is it fatal? Like, do you have to dissect them?
Yes. We have.
Any other question?
Do you think, since you're increasing the temperature, but you're not changing any feed, do you think later for the females it's going to affect their eggs? You know, unless you reproduce well?
Well, that's a good question, and that is something we would have to histologically look at when we sex them. We'll look at the gonads and see what difference we would observe in the ovaries when we look at them histologically. Thank you. I didn't think about
Thank
that.
you. Tell me,